Hello, how you doing? AWS Lambda plus Amazon Rekognition. As the name implies, this service gives you image recognition and video analysis capabilities. Rekognition is a machine learning managed service that builders can access via a simple API call. Builders don't need to have machine learning model building skills to use this service. Okay, so let's get started. So I'm going to quickly provide an overview of what we're going to cover in this video. First, I'll show you a quick system diagram of the system. After that, I'll show you a Lambda function setup with Python code that integrates with Amazon Rekognition. Next, I'll show you the results of running this Lambda function. After this, I'll step through some of the key Amazon Rekognition features. Lastly, I'll summarize some best practices when using Amazon Rekognition. Okay, so let's get into it. In this video, I'll be showing you a Lambda function that will be using the label detection feature of Amazon Rekognition. This function will make an API call to Rekognition requesting analysis of an image. Rekognition will provide a list of objects with confidence levels of what it detects in the image, and the Lambda function will print out those results to the console. So in this use case, a user is just going to run the Lambda function. They'll reference the image in the S3 bucket and then make the API call to Amazon Rekognition. First, I'll navigate to the Lambda service in the AWS console. Here, I'll click Manage Functions. Now we want to create a Lambda function, so I click Create Function. Here, I'll enter a function name, and I've selected Python 3.8 as my language runtime. I take all the other defaults, and I click Create Function. So now the AWS Lambda service auto-generates a default function for me. So just to quickly test it, I click the Test button. As many of you know, the first time you run a Lambda function, it wants you to find a test event. So I go ahead and enter an event name and click Save. Now I can click the Test button and see the results. It's a default 200 success message. This is what I would expect. So before I show you Python code, I'm going to make some configuration changes to the Lambda function. So I go click the configuration link, and in general configurations, I'm going to increase the Lambda timeout from 3 seconds to 1 minute. 3 seconds is not enough time for the Lambda function to make the API to Rekognition and get the results back. So I'm going to raise this to 1 minute, although it'll much likely execute much faster than this. In the permission setting, I'm going to modify the role associated with this Lambda function. I cover this in great detail in another video called AWS Lambda plus IAM roles. If you want to see this in detail, please check out that video. But at a high level, what I'm going to do is add additional permissions to this role so this Lambda function can execute. I'm going to add 2 additional AWS managed policies to this role. The first is Amazon Rekognition full access, and the second is Amazon S3 full access. Now, in a production environment, you'd want to add custom policies with finer granularity to give the Lambda function just what it needs to execute. But for this example, I'm going with this broader set of permissions. Now I'm going back to the code link, and I'm going to expand out the code editor in the AWS console. I've added the Python code for our example, and you can see here the entry point for this Lambda function is Lambda handler. Within Lambda handler, I define an S3 bucket and the name of the file I want Rekognition to analyze for me. And then I make a call to a Python function called detect labels. This Python function uses the AWS Boto3 Python library to get a reference to a Rekognition client object and makes an API call to have it analyze our image. When the response comes back, the Lambda function loops through and prints out the results. Here's the image I'm going to use in this Lambda function Rekognition example. It's a personal image of surfing a few years back, and now I'm going to go ahead and show you how to upload this into S3. In the AWS console, I navigated over to S3, and I created a folder called 001102 in a bucket named video-000110-bucket. Now I'm going to upload my image into this folder. Now I go back to my Lambda function and I click the test button. Looks like this Lambda function took 4.9 seconds to run, well below the 1 minute, but a little more than the 3 seconds. This Lambda function prints out all the objects Rekognition is detecting in the image. So in the response, we see that nature, outdoors, sea, water, sea waves, leisure activities, sport, and surfing come back with a confidence level of greater than 99%. So yeah, that all makes sense. It also sees the objects flare and light with about a 55% confidence. So there's a sun. This is a picture taken around 9 a.m. And so it's definitely, Rekognition is seeing that and not sure if it's a light or it's a flare, but this is pretty good. I think Rekognition did a pretty good job here. So again, this object detection or label detection is just one of the use cases that you can use Rekognition for. So let's talk about some others. So what are some of the features in Amazon Rekognition? Rekognition can handle facial compares in search. This might be, for example, finding faces in images or finding a specific face from a reference image. Face detection and analysis. This would be like determining whether someone's smiling or if they're sad or angry. Content moderation. This would be, looking for inappropriate content in an image. Text detection, looking for letters and numbers and phrases. Label detection. This is similar to what I showed in this example. Finding objects within an image and sharing that with confidence levels. Video segment detection, looking for transitions in video. And celebrity recognition, looking for famous people. So you can see that there's a lot of different use cases all around image analysis and video analysis that Amazon Rekognition can help you with. So what are some best practices with using Amazon Rekognition? Obviously, image quality helps quite a bit. Using images that are bright and sharp. Avoid using blurry images. It's good to use images where the objects have good contrast with the background. It's better to use color images over black and white. Again, that's more fidelity, more information about the image. And high resolution images are obviously better than low resolution images. So thanks for watching. Any videos referenced will be in the YouTube description. I invite you to watch other videos on my channel. And if you like the way I'm packaging this content, please consider subscribing. And one last thing, we all love technology and are excited about innovation with the cloud, machine learning, and AI. But don't forget to carve out some time to live in the real world. Get outside, go swimming, go hiking, go surfing, but anything to go move your body. And if you do, let me know in the comments. And with that, have a great day. Thank you.